Assalamualaikum warahmatullahi wabarakatuh. Today, me and my group will present about our group project for ITT550 Network Design Management, and we are going to present our enterprise network redesign for the Digital Innovation Division. So this is our group member, which is Haris, Ni'amah, and me, Aziz, and Ahmad Fikiran. So this is the company background. To give you some context, the Digital Innovation Division is a rapidly growing software development and cybersecurity consulting firm. Our co-operations and primary data center are located at our Shah Alam HQ. We also operate dedicated 24/7 Security Operations Center or SOC at our Cyberjaya branch. Because we handle highly sensitive proprietary source code and client vulnerability data, a secure and optimized network is the absolute backbone of our business model. Looking at our corporate structure, we support 120 employees across both locations. Under our Chief Technology Officer, our technical workforce is divided into three distinct pillars: 45 software engineers in Shah Alam, 40 security personnel in Cyberjaya, which includes our penetration testing team and defensive analysts and our internal IT management team. Highlighting this structure is important because this exact division of labor is what drives our network segmentation strategy later in the presentation. So this is a floor plan and current office infrastructure. Physically, our workforce is spread across a three-story HQ in Shah Alam and two-story facility in Cyberjaya. Currently, our hardware and workforce are tied together using an outdated infrastructure that simply cannot keep up with our growth. This brings us to our existing network design. Right now, this legacy architecture is a major business liability. First, it operates on a completely flat network architecture. This means our offensive penetration testers are sitting on the exact same logical broadcast domain as our HR and finance teams. If a test environment is compromised, the risk of lateral threat movement across the entire company is critically high. Beyond the security risk, we are dealing with several performance bottlenecks. Developers pushing heavy code repositories are experiencing massive latency over legacy broadband. Our wireless signal is weak because constant dropout for mobile employees. Most dangerously, there is zero redundancy. A single router failure will take the entire branch offline. To fix these critical vulnerabilities, we engineer a complete architectural overhaul.
Thank you very much, Niazi. Hi, my name is Maris, and I will be walking you through the core of our process network architecture. So, to resolve the severe latency and scalability issue at the Digital Innovation Division, we are replacing the legacy flat network with the Cisco 3-layer hierarchical design. For our Shah Alam headquarters, this compromises core, distribution, and access layers to ensure high-speed data transmission and robust security. For our Cyberjaya branch, we utilize a highly efficient collapse core model to provide enterprise-grade redundancy while still remaining cost-effective. So as you can see here is an example of what 3-layer hierarchical design looks like. Moving on to our logical network diagram, we implemented a private 10.0.0.0 IPv4 schema to establish clear routing segregation. We assigned the 10.10.0.0/16 block to Shah Alam and 10.20.0.0/16 to Cyberjaya. Critical departments are isolated in dedicated VLANs, ensuring that traffic and penetration testing never mixes with corporate administration. Layer 3 inter-VLAN routing is handled directly at the distribution layer using switch virtual interfaces, which activity controls and secure the flows of data between these boundaries. So as you can see, there is an logical network design that I have developed of our proposed network topology. So here is a closer look at the segmentation strategy. At Shah Alam, we logically separated management, development, admin, Wi-Fi, and core servers into their own 24 subnets. Cyberjaya mirrors this with the dedicated segments for branch management, the SOC team, and the pen testing environment. This strict isolation prevents broadcast storms and stops unauthorized lateral movement if any specific testing environment is ever compromised. Now, moving on to the physical diagram of our proposed network design. So, physically, this design is built to meet with a strict 99.9 uptime requirement. Our hardware topology utilizes physical cross-connection at all aggregation points. We deployed parallel fiber cables configured as layer 3 ether-channel links between our core switches to eliminate any single point of failure. Additionally, both sides feature resilient WAN cabling, securely wiring our enterprise to dual service providers through dedicated edge routers for automated failover. So as you can see here, these are the physical network diagram that is developed on the Cisco Packet Tracer software, which displays the accurate Cisco hardware and the hardware that is used for this network upgrade. So now moving on to the proposed floor plan of our network topology at the Digital Division Innovation. So as you can see, it is broken into two branches, which is Shah Alam and Cyberjaya. So this shows the clear floor plan for Shah Alam between ground floor, floor 1 and floor 2, and Cyberjaya ground floor and floor 1 as well. Finally, getting to the hardware session that we have chosen for this network upgrade. To bring this architecture to life, we selected a unified Cisco hardware stack. We use Cisco Catalyst 9500S for high-speed core switching, 9300S as the distribution layer for ACL enforcement, and 9200LS as the access layer for PoE plus endpoint delivery. Our perimeter is secured by Cisco Firepower 1010 firewalls, and our dual WAN failover is managed by 4331 edge routers. So, this unified ecosystem guarantees seamless integration and centralized management for the division. Thank you.
Okay, let's take a look at our local network setup. So as you can see right here on the slide, we've broken our routing and security down into three simple blocks. That is the isolation, the routing, and the ACLs. So if you check at the first block on the left, we've completely abandoned the old flat network layout. So we are now using dedicated VLANs to isolate key zones like web theft, and penetration testing into separate domains. So moving on to the middle block, our inter-VLAN routing is actually handled by switch virtual interface on our distribution layer switches, which gets data moving between subnets at true wire speed. And finally, as shown in the last block, we lock this pass down using strict hardware ACLs to completely block lateral thread movements. Moving on onto performance, so this slide highlights how we hit our 99% uptime requirement using the two technical pillars, that is the RPVST Plus and the Ether channel. So first, the RPVST Plus manages our redundant switch uplinks to eliminate loops and guarantee sub-second failover if a cable drops. Second, as you can see on the right, we use LACP Ether channel to bundle our physical links and effectively doubling our backbone bandwidth for heavy data traffic while balancing the load automatically. As you can see in the picture, this diagram shows our secure remote network triangle. The solid baseline is our permanent side-to-side VPN using the AES-256 encryption, while the dotted lines show our client side-to-side VPN using the Cisco Interconnect. Finally, as highlighted in the box on the bottom right, we enforce strict multi-factor authentication and endpoint profiling to keep the entire core safe. The picture shows our network topology aggregates down to the ground floor where we deployed a central wireless LAN controller. This allows our developer to roam seamlessly between floors without dropping active session. And finally, as noted in the bullet points on the left, we are using the Wi-Fi 6 standard for high device density, and we've completely locked it down using strict WPA3 Enterprise with 802.1x authentication.
Next, I will explain the WAN technology used in our proposed network. To ensure reliable communication between Shah Alam headquarters and Cyberjaya branch, we implement a dual WAN strategy. The primary connection uses TM1 fiber, which provide high-speed and low-latency communication for daily business operations. As a backup, we use Massive Business LTE. To maintain continuous connectivity, the Cisco ISR 4331 routers use IP SLA to monitor the primary connection. If the fiber link fails, the router automatically switches traffic to the LTE backup without interrupting network services. This design helped the company achieve its target of 99.9% network availability. Moving on to network security, our design follows a defense in-depth approach, which means multiple layers of security are implemented throughout the network. At the network perimeter, we deploy Cisco Firepower next generation firewalls to inspect traffic and block cyber threats. We also use VLAN segmentation and access control lists or ACLs to separate departments and prevent unauthorized users between them. In addition, port security protects the access switches from unknown device, while VPN encryption and multi-factor authentication or MFA secure remote user access. Together, these security measures help protect the company's sensitive data from both internal and external threats. To simplify network administration, we use several centralized management tools. SNMP version 3 allows administrators to securely monitor network devices and their performance. Cisco NetFlow provides detailed traffic analysis, making it easier to identify bandwidth usage and network issues. Meanwhile, all system logs and security events are stored in a centralized syslog server, allowing administrators to troubleshoot problems more efficiently and respond quickly to security incidents. Finally, our proposed network is designed to be both cost-effective and sustainable. The Cyberjaya branch uses a collapsed core design, which reduces hardware costs while maintaining reliable performance. We also implement Wi-Fi 6 to support more users with fewer access points. In addition, power over internet scheduling helps reduce electricity consumption. Overall, this design lowers operational costs while supporting the company's future growth.